I don't understand. What is your purpose here?
If civilizations are common, then there should be civilizations ahead of us, because there's been so much time. You imagine the timescales. We've been around, say, 40,000 years. I don't know how long our civilization's been around, let's say that. The galaxy is pretty much as old as the universe. It's 13 billion years worth of time. So the idea that there are no civilizations arose, 100 million years ago, 200 million years ago, 1 billion years ago. And imagine what they'd be like if they'd survived. I mean, we've had science for, let's say, since Newton or Copernicus, 500 years at most. And look what we've done. We've gone beyond the solar system with Voyager. We've walked on the moon. We're about to go to Mars, I would think. So we're about to begin colonising our own solar system. So we've done that in 500 years. Imagine 1 million years. It's one of the arguments often used to say there aren't any civilizations out there in the galaxy. It's called the Fermi Paradox. Because if you imagine a civilization that's 1 million years ahead of us, they should have written their presence across the sky by now. You should see them. I mean, you'll see us. If we survive 1 million years into the future, actually even a few thousand years into the future, we will be exploring the galaxy. We will have spacecraft that are going to other stars. We will be doing it. So our signature will become visible, I'm sure, if we last.
Is Earth the lone oasis of life, or is the universe teeming with hidden organisms waiting to be discovered? The vast number of stars, each potentially harboring planets with conditions ripe for life, leads many scientists to believe we can't be alone. The very elements that sparked life on Earth, carbon, hydrogen, oxygen, are abundant throughout the cosmos. Could this be the cosmic recipe for life, a universal secret shared across the galactic canvas? Join us as we embark on an unparalleled journey to unlock the mystery of life beyond our world.
If you look at the history of life on Earth, then, so Earth formed, there was no life, it was a ball of rock. And almost as soon as it cooled down, we see evidence of life. So certainly 3.8 billion years ago, possibly even further back than that, we see evidence of life on Earth. So somewhere along the line, geochemistry, active geochemistry, became biochemistry on Earth. And we have some idea, if you get gradients of temperature and acid and alkaline and the conditions that are naturally present on the surface of oceans, then complex carbon chemistry spontaneously happens. So we know that life, almost certainly we know that life began on Earth. The other option is it came from space or something like that, but it probably didn't, right? It probably began on Earth. So that means that at least here, that happened. And that we know that the conditions that led to the origin of life on Earth were present on Mars 4 billion years ago. And we know that they're present on Europa today. So I don't see that there's anything special. Life is just chemistry. The idea that geochemistry becomes biochemistry is not fanciful because it happened here. So I think that given the same conditions, it would be surprising to me if the same thing didn't happen, in that life begins. To test that is one of the great frontiers of science now. It's one of the great challenges. So it would be good to know if what I've said is right. The way we find out is to find life or evidence of past life.
The universe may be filled with life, so why haven't we found any evidence yet? This perplexing question is known as the Fermi Paradox. Some propose the zoo hypothesis, suggesting that extraterrestrial civilizations might be watching us, intentionally avoiding contact like zookeepers observing animals. Meanwhile, the recent surge in UFO and UAP reports has stirred excitement and curiosity. But are these truly indications of otherworldly visitors? Despite tantalizing stories and sightings, solid proof remains elusive. The galaxy remains a silent, enigmatic void withholding its secrets. But who knows, really? Could the answers be just beyond our reach, waiting for the right moment to reveal themselves?
That point, it seems to me, once you've said I don't know, you might as well put a full stop there and shut up. I don't know, but then I think this. It's like someone asked me the other day about unidentified flying objects. There's this congressional panel on UFOs. And I said, the thing is, it's in the words, isn't it? It's just unidentified. So should we just show up now? It's unidentified, therefore, I think there's an alien civilization close by that's building flying saucers that are trying to evade our defences, and there's a big cover-up, and the CIA are not telling us everything. So no, unidentified, that's it. I don't know what they are.
The Fermi Paradox continues to baffle us, a cosmic conundrum echoing through the void. If the universe is teeming with life, why is the evidence so elusive? Some argue that technological limitations hinder our search, confining our gaze to a mere sliver of the galactic expanse. Others believe that the Great Filter, an unknown barrier to the advancement of civilizations, might be preventing species from reaching a point where we could detect them. Could it be that life is abundant, but intelligent life is exceptionally rare? Or is there something more profound, a hidden truth veiled by the vastness of space itself, awaiting our discovery?
There is an argument as well that technology so advanced would be difficult for us to detect. I mean, we tend to think of Star Wars, right? Big energy things that you can see the signature of. But actually, maybe the civilization just becomes a nano civilization because that's more efficient. It's a better way to do things. So it's possible, I suppose, that there are space probes all over the place that are so small and are so efficient and use so little energy that we just don't see them. I suppose that is possible.
The Great Filter hypothesis presents a chilling explanation for our cosmic silence. It suggests that somewhere along the path to becoming a spacefaring civilization, there's a nearly insurmountable barrier, a filter that prevents advancement. Is this filter behind us, making our existence a rare triumph against astronomical odds? Or is it ahead of us, a future obstacle that might extinguish our civilization as it has possibly done to others before? The Great Filter looms large in our search for extraterrestrial intelligence, casting a shadow of both hope and dread. It's a theory that forces us to confront not only our place in the universe, but our future within it.
There's in the Drake equation, which wasn't to try to estimate the number of civilizations, really. It was to try and focus your mind on what the variables are, how you should think about it. But at the end of that, the way that he wrote it, there's an L, the letter L, which is the length of time a civilization will be broadcasting or contactable through radio waves. And I mean, we've been around in that form, which is with radio telescopes. I like it that astronomers define civilization as when did you get a radio telescope? Then you're civilized. And it's less than 100 years. So we've only been, that L for us is the contactable lifetime of civilization. It is 100 years or so for us. We could have gone, you think about the Cuban Missile Crisis, for example, that could have been 20 years for us. We're still in that position. How long is L? How long is the lifetime of civilization once it acquires nuclear weapons, for example, which it will? How long does your civilization manage that? It's not clear. We're doing the experiment, and we've dodged it a few times.
When might the Great Filter arise? Some propose it occurs in the early stages of life, where the spark of existence is snuffed out by harsh cosmic realities. Others argue it may surface later when intelligence emerges, presenting challenges that civilizations struggle to overcome. The development of complex technology, though a sign of advancement, could also mark a dangerous precipice. Take nuclear weapons, for example, a marvel of human innovation, yet a potential harbinger of our own destruction. Could they represent a great filter, a threshold that has annihilated other civilizations before us? The answers may define not only our quest to find extraterrestrial life, but our very survival.
Oppenheimer thought about this a lot because on the Manhattan Project, he'd felt himself responsible for creating the bomb. You can look at it many ways. You can say that he shortened the war in the Pacific, or you can say that he invented this thing that we don't have the wisdom to control. He was very worried about what he'd done. He just strongly felt, and he might still be right, that we didn't have the wisdom to control the knowledge. So it could be the case. So that could be another answer. So the great silence that people call the Fermi Paradox might just be because we are fundamentally idiots. The great stupidity. Intelligent beings are fundamentally just dumb. They erase themselves from the universe. I challenge anyone who's listening to argue that there's at least a possibility that that's what we are.
The Great Filter hypothesis delves deeper into the haunting silence of the cosmos, offering a profound explanation for our isolation. Could it be that every civilization faces a series of critical barriers, tests that must be overcome to reach the stars? These barriers might include surviving planetary catastrophes, avoiding self-annihilation through warfare, or navigating the perils of unchecked technological advancement. The Great Filter posits that few, if any, traverse this perilous path successfully, hence the quiet universe. It's a theory that resonates with both optimism and warning, urging us to reflect on our choices and the universal journey we share.
The way I look at life is that it's the most important phenomenon that exists in the universe. Without life, the universe is, by definition, meaningless. Clearly, meaning enters the universe with consciousness, and consciousness is a property of living things. And so, without living things, there's no meaning. So I think that if this is the only planet in the Milky Way galaxy that currently hosts an intelligent civilization, then it's the only island of meaning in a sea of 400 billion stars. And therefore, we have a tremendous responsibility to protect this island of meaning. If we mess it up, we will be responsible, if that's the case, for annihilating meaning, perhaps forever, in a galaxy. So I think life's important.
In our quest to understand the universe, we've explored the tantalizing possibilities of life elsewhere, grappled with the enigma of the Fermi Paradox, and delved into the profound Great Filter hypothesis. From the basic elements forming life to the silence echoing across the cosmos, our journey reveals both hope and caution. But as we gaze into the infinite void, one question ignites our curiosity and fuels our imagination. In this vast, mysterious universe, are we the exception or the rule? Is the key to unlocking alien life within our grasp? Or is the secret buried deeper in the cosmos than we ever dared to dream?